Hello, today we're going to talk about solving matrix equations. Now, matrix equations basically come in kind of three flavors. They come in what we just simply call a matrix equation. Basically, it's an equation made up of matrices. Um, and then the second one, which we will talk about um, more in depth later on, is a linear system written as a matrix. Okay, so I have here three matrices. You'll notice that they're all 2 by 3. Now, when you solve a traditional matrix equation, that's kind of what you need. You need to have all of the matrices be the same size because your answer will be a matrix of the size that you start with. So, with a matrix equation, your answer will be a matrix of the given size. Okay, so we're going to start out with just a very simple one. We're going to have X, matrix X, the unknown matrix, okay, and here's our first equation. So we're going to have A plus X equals B. Okay, so think about how you would solve this just for the matrix X. Think about, math 1, math 8. So if you want to solve for X, you would just simply go minus A on both sides. So the matrix X is the matrix B minus the matrix A. So now, since we have that solved, we substitute. Another thing you will notice with these is we're not using any sort of matrix multiplication. We will use a scalar, but we won't use matrix multiplication, row times column. Okay? So distribute your negative if you need to, or you can do it in your head, doesn't matter. I'm going to go ahead and distribute that negative. Now remember, when you distribute the negative, make sure it goes all through to all 6 elements that are there. So 2, -1, -3, 1, 0. And now we're going to combine and get our final answer. And that's it. Okay, so let's try something just a little bit more complicated. Right? Okay, this isn't actually too bad because the only thing that you're really doing is you have a scalar of 3 multiplied to your x. We have a 2 times an a, and then on the other side we have 2b plus c. So what we're going to do is we're going to solve for x until we get to the 3. Okay, we're going to do that on the very last. So what I'm going to do is I'm going to subtract the 2a, both sides. So I wind up with something that looks like this. So now what I'm going to do is I'm going to go back and I'm going to substitute. So I'm going to kind of shrink my screen here so I can see. So 3x, 2, 0, 2, -4. Okay, so there's 2b plus c. Okay, and then minus 2a. Now, these are not difficult. However, they can get a little bit tedious, okay, because there's a lot of numbers for you to deal with. Okay, so I'm going to do my scalar multiplication first, and then I'll do my combining. Okay, here we go. And again, if you can do this process faster by doing it in your head, that's perfectly fine. Okay, I'm going to go ahead and distribute that -2 in, so the outside changes to a positive. Okay, so I've done my scalar, and now I'm just going to add by element. So I still have that 3x, so I'm going to add. Okay, now I'm going to simplify. Okay, so there I have 3 times x. Now, to take care of that 3, what I'm going to do is I'm going to multiply by the reciprocal, because it's actually easier to see. So I'm going to go 1/3 times 3x is equal to 1/3 times my matrix. And I'm going to get fractions, and that's perfectly fine. And now I'm going to use scalar multiplication by 1/3. So 1/3 times 3 is 1, then -2/3, then -2, 11/3, 5/3, -16/3. And then we're done. Okay, so not too bad. Okay, now the second type of matrix equation that you will solve will have to use the inverse matrix. Okay, so we're going to write using the inverse matrix. And that's when you have an equation like this. Okay, so notice it's not a scalar, you have a matrix times a matrix. Okay, this is most typically seen with a linear system setup. Okay, so what you would do is you want to get basically a 1 next to your x matrix. Now, in matrix arithmetic, we call that the identity matrix. So what you would do is you would multiply both sides on the same side. So notice it's left, your A inverse is on the left-hand side each side. That's because matrix multiplication is not commutative. So if you multiply a matrix by its inverse, you get the identity matrix. Okay, and then the identity matrix times x would just be, so this would be your answer. Okay, so we use this to solve linear systems. So a linear system you have dealt with before. It looks like this. Okay, so way back when, before this year, you had 3 strategies. graphing. We had substitution. And then we had elimination. So now we're going to add a fourth strategy, and we're going to use matrices. Okay, so the basic setup for this is you're going to turn your linear system into a matrix equation. So it's going to look like this. You're going to have your coefficient matrix. And then you're going to multiply that by what we call the variable matrix. Oops. And then that's going to equal what we like to call the constant matrix. Okay, so this is your A, this is your X, and this is your C. All right. Okay, so this particular system, if we were write it as a matrix, would look like 4, -2, 3, -5. Notice that those are all the coefficients of your variables, x and y. The x's are in one column, the y's are in the second column. Do not mix them up. Your variable matrix is xy, and that is equal to your constant matrix, which is 10, 1. Okay, now we're going to solve it. So first, find A inverse. We're going to use our formula because it's a 2 by 2. If it wasn't a 2 by 2, then we would use our matrix calculator. Okay, so let's go ahead and do that. So our determinant is going to be, let's see, 4 times a -5 minus 3 times a -2. Okay, and then we're going to do -5, 4, switch, 2, and 3, change the signs. Okay, so now I have -20 plus 6 times. Now there's going to be a lot of fraction work, but that's okay. So -1/14 times -3, -5, sorry about those switched. Okay, so now let's multiply. And you can see why I maybe said that, you know, this is a bit much. Okay, for a little, you know, 2 variable linear system, it's a bit much. So, you know, you can always go back and use elimination or substitution. I'm not going to tell. Okay, so now since we have my inverse, I am ready to solve. Okay, so take your inverse. Notice I haven't reduced anything. And then we're going to multiply it. Okay, so we have a 2 by 2 matrix multiplied by a 2 by 1 matrix, so we're going to get another 2 by 1 matrix out. Okay, oops. That was interesting. Okay, here we go. Okay, 5 over 14 times 10 is 50 over 14, and then negative 2 over 14. And we're going to move down. Then 30 over 14 minus 4 over 14. Okay, so that would be 48 over 14, and then 26 over 14. If I reduce my answers, I get 24 over 7, and then 13 over 7. And this is x and y. And that's how you solve a system of equations by using matrices and the inverse matrix. Okay, now we are going to do a 3 by 3, but we will use the calculator for that. Okay.